protect roof-mounted utility transformers from lightning, consider these best practices. Firstly, install Type 1 or Type 2 surge protection devices, or SPDs, between the transformer input or output lines and ground. These SPD divert surge currents from lightning strikes to the grounding system, effectively protecting the transformers. Secondly, consider installing lightning rods or air terminals on the highest point of the roof. These devices attract lightning strikes and channel the current through a conductive pathway to the grounding system. Thirdly, enclose the transformers in a metal Faraday cage. The metal cage provides a conductive path for lightning currents, diverting them around the transformers and protecting them from direct strikes. Fourthly, establish a robust grounding system with multiple ground rods and a low resistance path to earth. The grounding system provides a safe and direct path for lightning currents to dissipate into the earth, minimizing the risk of damage to the transformers. Fifthly, use shielded cables for power lines and grounding connections. Also install surge-suppressing devices on control lines to protect sensitive electronics from voltage spikes. Sixthly, inspect and test the lightning protection system regularly for damage or corrosion. Replace worn or damaged components as needed to maintain optimal protection and ensure the system functions effectively. It is also important to conduct a thorough risk assessment to determine the level of lightning protection required for the specific location and transformer setup. Ensure the lightning protection system complies with local codes and industry standards such as IE 1100, recommended practice for powering and grounding electronic equipment, and NFPA 780, standard for the installation of lightning protection systems. Engage a qualified electrical contractor to design and install the lightning protection system, ensuring it is properly integrated with the existing electrical infrastructure. Lastly, inform the utility provider about the lightning protection measures to ensure compatibility with their equipment and avoid any potential conflicts or issues. Lightning protection systems work by providing a low impedance path for lightning energy to flow to ground, thereby minimizing the risk of damage to the protected equipment. The grounding system is a critical component of any lightning protection system. It should be designed to provide a low resistance path to earth, allowing lightning currents to dissipate quickly and safely. The grounding system should consist of multiple ground rods interconnected with a heavy gauge conductor. The conductor should be bonded to the building's structural steel and other metallic components to create a common ground plane. Surge protection devices, or SPDs, are designed to protect electrical equipment from transient voltage surges caused by lightning strikes and other events. SPD are installed in parallel with the equipment they are protecting and divert surge currents to ground. There are different types of SPD available, each designed for specific applications. Type 1 SPD are typically installed at the service entrance of a building and provide protection against direct lightning strikes. Type 2 SPD are installed at downstream distribution panels and protect against indirect lightning strikes and other transient voltage surges. Type 3 SPD are installed at the point of use and provide protection for sensitive electronic equipment. Lightning rods, also known as air terminals, are designed to attract lightning strikes and channel the current to ground. Lightning rods are typically installed on the highest points of a building or structure. They are connected to the grounding system with a heavy gauge conductor. The conductor should be routed as directly as possible to the grounding system to minimize impedance. A Faraday cage is a conductive enclosure that protects the equipment inside from electromagnetic fields. In the context of lightning protection, Faraday cage can be used to protect transformers and other sensitive equipment from lightning strikes. The Faraday cage provides a conductive path for lightning currents, diverting them around the equipment inside. The cage should be constructed of a metal mesh or solid metal sheet and should be properly grounded. Regular inspection and maintenance are essential for ensuring that a lightning protection system is functioning properly. The system should be inspected at least annually for damage or corrosion. Any damaged or corroded components should be replaced immediately. The grounding system should be tested periodically to ensure that it is providing a low resistance path to earth. A qualified electrical contractor should perform the inspection and testing. In addition to the measures, consider the following. Firstly, conduct a lightning risk assessment. This assessment will help determine the level of protection needed based on factors such as the frequency of lightning strikes in the area and the importance of the equipment being protected. Secondly, ensure compliance with codes and standards. Adhering to standards like NFPA 780 and IEE 1100 ensures that the lightning protection system is designed and installed correctly. Thirdly, engage a qualified electrical contractor. Professional installation is crucial for the effectiveness of the system. A qualified contractor will have the expertise to design and install a system that meets the specific needs of the facility. Fourthly, coordinate with the utility provider. Informing the utility provider about the lightning protection measures helps ensure that the system is compatible with their equipment and that any potential issues are addressed proactively. Proper wiring and connections are also important for lightning protection. Shielded cables should be used for power lines and grounding connections to minimize the effects of electromagnetic interference. Surge-suppressing devices should be installed on control lines to protect sensitive electronics from voltage spikes. These devices can help prevent damage to equipment and ensure that it continues to function properly during and after a lightning strike. By implementing these lightning protection measures, the risk of damage to roof-mounted utility transformers can be significantly reduced. This will help to ensure the reliability of the electrical system and prevent costly downtime. When selecting surge protection devices, it is important to choose devices that are rated for the specific voltage and current requirements of the equipment being protected. The SPD should also be installed in accordance with the manufacturer's instructions. The grounding system should be designed to meet the requirements of the National Electrical Code, or NEC. The NEC provides detailed requirements for grounding and bonding electrical systems. The grounding system should be inspected regularly to ensure that it is in good condition and that all connections are tight. Lightning rods should be installed in accordance with the requirements of NFPA 780. The lightning rod should be properly grounded and should be positioned to provide adequate protection for the building or structure. A Faraday cage should be constructed of a conductive material, such as copper or aluminum. The cage should be grounded to the building's grounding system. The Faraday cage should be designed to completely enclose the equipment being protected. Regular inspection and maintenance of the lightning protection system is essential for ensuring that it is functioning properly. The system should be inspected at least annually by a qualified electrical contractor. Any damaged or corroded component should be replaced immediately. The grounding system should be tested regularly to ensure that it is providing a low resistance path to earth. The lightning protection system should be designed to protect against both direct and indirect lightning strikes. Direct lightning strikes can cause significant damage to equipment. Indirect lightning strikes can cause voltage surges that can damage sensitive electronic equipment. A comprehensive lightning protection system should include surge protection devices, lightning rods, and a Faraday cage. The system should be designed to meet the specific needs of the facility. A qualified electrical contractor can help to design and install a lightning protection system that will provide adequate protection for the equipment being protected. By implementing these lightning protection measures, the risk of damage to roof-mounted utility transformers can be significantly reduced. This will help to ensure the reliability of the electrical system and prevent costly downtime.